Now we're going to see the circular paraboloid or paraboloid of revolution. The circular paraboloid is a paraboloid. The equation of the paraboloid was x squared divided by a squared plus y squared divided by b squared equals c divided by c. The circular paraboloid, as you can guess, is when x squared divided by a squared plus y squared divided by a squared equals c divided by c. That is when a is equal to b in the normal paraboloid, or in the ellipsoid paraboloid if you would like. So a is equal to b, so you have x squared divided by a squared plus y squared divided by a squared equals c divided by c. So the interesting thing with this circular paraboloid is I drew again the paraboloid because the a and b are the same. So in this ellipse you have that a that is in the direction of x, this is the same as b. We not have an ellipse, we have now a circle. So that means that if you do horizontal cross sections of the surface, you have circles centered at the axis in which the paraboloid is opening, so it would be centered in C, in the C axis. Next is the parabolas that you have when you do cross section in the planes that contain C, that is in the XC plane, in this plane, and in the CY plane. The parabolas that you got now have in common the focus. If you remember, a parabola, let's say in the XY plane, here's Y and here's X, you have a focus of the parabola, a directrix. The important here is the distance from the center to the focus. This is for this is the distance. Let's say n is the distance from the center of the parabola to the focus. If you remember the equation of the parabola, let's say this parabola is y is equal to 1 divided by 4 times the distance of the focus, x squared. So this is the equation. So if you have this equation, if you do a cut, let's say through the YC plane, so this is in the x equals 0 plane, so x equals to 0, so you have y squared over a squared is equal to c over c, so you have c is equal to c divided by a squared times y squared. You know that 1 divided by 4 times the distance from the center to the focus is equal to c divided by a squared. If you want to know the distance from the center to the focus, you have f here, I squared here, and c here. So you have f is equal to a squared, or square a, divided by 4c. So the distance from the center to the focus of the parabola that we got when we do a cross section from the C or YC plane is that's this parabola, the blue one, and the focus is, let's say, here. That is in a distance from the center of I squared, or square I divided by 4c. The same is true if you do a cross section through the XC plane, so you would have x squared divided by square a equals c over c, and the same story, c is equal to cx squared divided by a squared, and you have again the distance from the center of this orange parabola would be again a squared divided by 4 times c. So in the circular paraboloid, we have in horizontal cross sections, you see circles centered at the, in this case is at the c-axis, but if instead of having here c, let's say you put, I don't know, let's say c minus 2, so would be centered, well, instead of having like, oh no, yes, it still will be centered, just instead of having it here, you will have it up. Alright. Now if you want to change the center in this parabola, you change it moving here, the y or the x. Well, anyway, so there are circles if you do horizontal cross sections, and the other issue is that if you do sections through the planes that contain the axis in which the paraboloid is opening, you have parabolas, and both parabolas, that is, if that's the parabolas that you got in the CX plane code and the CY plane code, are parabolas that in common have the distance from the center to their focus, that is a squared divided by 4 times c. And these paraboloid, these circular paraboloid, are we see them in many applications, that is, for example, in the antennas.